Hi everyone, this video is about partial derivatives and I will explain functions of two variables, then I will go through the partial derivatives with respect to both x and y, then I will give you the alternative symbols for partial derivatives and then we will go through the high order and mixed derivatives and also the alternative symbols for those derivatives. And at the end, I will talk about the chain rule for the functions of two variables. So let's start with the functions of two variables. I took this figure from the textbook in which we can see the definition of a function of two variables. So a function of two variables is a rule of correspondence that assigns to each ordered pair of real numbers x and y of a subset of the xy plane, one and only one number z in the set of R of real numbers. The set of ordered pairs x and y is called the domain of the function, and the set of corresponding values of z is called the range. The function of two variables is usually written as z equals to f of x and y, and in here, the variables x and y are called the independent variables of the function, and z is called the dependent variable. And in 3D, the graph of a function z is a surface. Now let's define the level curves. Let's say that this is our graph in 3D space. The level curves of function f are defined by the constant values of z. So let's say that this is plane Z is equal to C. Then the intersection of this plane and our surface will be here, where this is f of x and y equals to C. And we can interpret this as the projection onto the xy plane of the curve of intersection. These two shapes are exactly the same thing. So this curve on the plane of x and y will be here, and we call this the level curve. So this is the level curve. Now let's define the partial derivatives. We know that the derivative of a function of one variable is given by this equation. Using the exact same manner, we can define a derivative of a function of two variables with respect to each variable. This is the differentiation with respect to x, and this is the definition of the differentiation with respect to y. Note that in the first one, since y is only a function of x, then its derivative with respect to x will be a total derivative that we show it with d. But in here, since z is a function of both x and y, then the derivative of z with respect to x will be a partial derivative. And we can see that in the definition of the partial derivative of z with respect to x, y is not changing in the limiting process. So we can say that to compute the partial derivative of z with respect to x, we can use the laws of ordinary differentiation while treating y as a constant. And here in this definition, you can see that the partial derivative of z with respect to y in this limiting process, x is not changing. So we can say that to compute the partial derivative of z with respect to y, we can use the laws of ordinary differentiation while treating x as a constant. There are also alternative forms to show these two symbols, and we can show them as z sub x and z sub y. Or instead of partial z partial x, we can write partial f partial x. And again, similarly, instead of writing the fraction, we can write f sub x and f sub y. But what about higher orders and mixed derivatives? For example, we can write the third order partial derivatives of z with respect to x and also with respect to y. So the third order derivative will be equal to the derivative of the second order derivative or the derivative of the first order derivative. Also, these have some alternative symbols. Again, instead of fraction, we can write them as subs, and also instead of z, we can write f. But what about the mixed partial derivatives? Here is the second order mixed partial derivative, where we need to find the partial derivative of z with respect to y and then find the derivative of that with respect to x. Also, these have some alternative symbols. Again, instead of fraction, we can write sub, and instead of z, we can write f. Now let's extend the chain rule for the functions with two variables. Let's say that z is a function of u and v, where both u and v are a function of x and y. So now what will be the partial derivative of z with respect to x? In order to find this, we need to first to find the partial derivative of z with respect to u, and then partial derivative of u with respect to x. Then we need to add the contribution of v. So we need to find the partial derivative of z with respect to v, and also the partial derivative of v with respect to x. And similarly, we can find the partial derivative of z with respect to y. So this is the chain rule, and the assumption is that z, u, and v have continuous first partial derivatives. Now let's take a look at a special case where z is a function of u and v, and u and v are differentiable functions of a single variable. Now, since u and v are a single variable functions, we can find the total derivative of z with respect to t, which will be equal to the partial derivative of z with respect to u times the total derivative of u with respect to t plus the partial derivative of z with respect to v times the total derivative of v with respect to t. So as you can see, since z is a function of two variables u and v, then its derivatives are both partial. But since u and v are only a function of one variable, so their derivatives are total derivatives, and we show them with D. So now we can form a tree diagram. Now let's say that we have z, which is a function of u, v, and w, where u is a function of t, v is a function of x and y, and w is also a function of t. Now we can form the derivatives. So in here you can see that since z is a function of three different variables, we have partial derivatives. Since u is only a function of t, it's one single variable, we have a total derivative. And similarly for w, we have a total derivative. And for v, since it's a function of two different variables, we will have partial derivative. And now if we want to find the derivative of z with respect to t, we have t1 here and 1 here. And both of them are the total derivatives. So we will have a total derivative of z with respect to t, which will be equal to these two. Similarly, if you want to find the derivative of z with respect to x, we have x here, and we need to use this branch. And partial z partial x will be equal to, if you enjoyed this video, please subscribe to my channel and turn on the notification if you want to get notified whenever I post a new video.